Hello everybody, welcome back once again to another lutys chainsaw mods. I'm working on this little Chinese dyno clone at the moment. It's been running well. This is the one that pushes 8 horsepower. It's been doing really well, this saw has. It's been out with me quite a few times, done quite a bit of work. She was running great. I was taking a tree down about a week ago, I think it was, week and a half ago or whatever, and it started to spit back and play up, and then it was like hesitating when it was revving. So it's the first time I've had a chance to look at this really. I mean, it was something that's relatively simple, but the carburettor had come loose from the cylinder and it had kind of taken one of the threads really. So this chainsaw is the one, it's heavily modified throughout this saw. And that's how I've got 8 horsepower out of it. I mean, it was a 3.1 horsepower saw, this 58cc is an hour clone, and as you can see, literally everything on this chainsaw is modified on the engine. So I got one of my short expansion chambers that I'd made for it, and this works fantastic. When I first dyno tested it, I mean, if you don't watch my channel, then there's a dyno there, look, that I can unbolt off my bench and what have you, that I made. As some of you all know that watch my channel, I do a fair bit of dyno testing. But that's how obviously I know I've got 8 horsepower out of this chainsaw. So yeah, it's got one of my expansion chambers that I make, short expansion chambers. It's got a heavily modified cylinder on it. I've put some venting holes around the top, extra venting holes around the top. It's heavily ported inside. Compression's raised quite a lot. Let me see, I think it's 0.85 of a millimetre on the squish band. It's got a pop-up piston. It's also got a turbo crankshaft, which basically encourages the fuel air mix to go out sideways and up the transfers, because the transfers on these are just either side, large wide open transfers. But when I first built this, I did a dyno test on it, and it was before I built this expansion chamber, and it was pushing 6 horsepower. But once I'd done that, I finished off the expansion chamber that I'd made, and it gave me another 2 horsepower, 2.01 horsepower according to my dyno, extra, just by putting that on. Now, I'm not saying expansion chambers aren't really there as a bolt-on power conversion. You know, it won't necessarily, it's not necessarily going to make a standard chainsaw any more powerful really. It might be slightly, but not really. So I mean, the idea of this is that because it's got a Husqvarna 372 carburetor, which has got a 26mm bore through the carburetor. Now if you can see down the back here, let me just get a pointer. You can see down the back, you can probably see, see the orange piece there. That's one of my wide open intake manifolds that I make there, made out of steel. Big 372 Husky carburetor, 26mm bore. Now they were originally, these engines are 18mm at the carburetor. Obviously, like I said before, heavily ported, pop-up piston, turbo crankshaft. I haven't advanced the ignition timing. To be honest with you, I don't think I'm going to bother. You know, I mean, I'm getting 8 horsepower out of this thing now. But anyway, the crux of the issue was that the carburetor had come loose. If you know these saws, the bolts go through the carburetor. The mounting bolts go through the carburetor, one each side. Bolt it to the cylinder. Now that's better. You can see that a bit better now. So yeah, bolt it to the cylinder, and it basically, I did away with the air filter in the end. I did different experiments on air cleaners, and I found this ram stack with, it's got mesh on it, but also I've got a very fine material on the outside which I put on it, and it's set up perfectly. This is really good, to be fair. It breathes really well. So that goes on there. There's a couple of grub screws either side that you can pinch up just to tighten it out. Now, because originally the carburetor is mounted straight through the carburetor and then onto the intake at the back, and then eventually it gets mounted by separate bolts onto the cylinder. You know, they vibrate a lot, these two strokes, obviously. So of course you got it vibrating a heck of a lot, and with the extra weight of the ram stack that it's got on it, eventually it started to pull the bolts out of the cylinder at the back. So I thought, okay, it's a relatively easy fix to put it right, but I need to make sure it ain't going to do it again. So what I've done, I'll take this off, might be able to show you a bit easier with that off. So what I've done is I've made, so this was the adapter. This is basically the adapter for that ram stack, okay, which is basically a very large piece of steel plate with a hole cut in the middle and bolt holes, etc., as you can see. And then I made a piece of tube, and I've angled it slightly so it's shorter at the top. At the bottom it's got an upward angle. It has to have that so that you can miss the handle with the ram stack. I've had to cut my handle down a little bit here to make sure it misses the ram stack. And if you can see under here, look, I've cut the actual casing out. So all this aluminium section, which is not really there for any purpose other than closing the back up, but I cut all that out. And just under there, can you see that red plate that runs along? That's the that's now the securing mounting for all this, so it will keep it really secure. I've got there's a screw under there, look, an Allen screw under there that goes into this red mounting, and then I've got another one which is, I'm just trying to see what you can see, Got another one which is just inside here. It's just above the mountain. Ah, there it is. Can you see it? Another Allen screw in there, which is just above the mountain, the rubber mountain. And that also, again, goes onto this plate. Goes onto that plate. So it's, yeah, it's really secure now. It's, you know, well, hopefully it is. It seems to be really secure. It's now supporting the back end properly. So hopefully it shouldn't come loose again. We'll see how that goes. It did run for quite a while with it like this, without that plate, that bracket at the back. It's a good saw, this. It's I've managed to drop the speed on it a little bit because this is the one that was pushing 18,500 RPM, and it was just useless. It was just ripping chains all up. Too fast. So I rebuilt the engine because it had knackered all the bearings and everything. And I've managed to reduce the speed. Part of it is the expansion chamber, because it's just got a single outlet on it now, as opposed to twin outlets, which the Dynos normally have a twin outlet. So it's got one outlet there. I've also got some thermal wrap around my exhaust, which should be keeping the crankcase cooler, to allow the air fuel mix to stay as cool as possible. And like I say, it's in this form, it pushes 8 horsepower now, which is a lot for a 58cc chainsaw, let alone a Chinese one. So I like these saws. I think they're really good. They're robust. I mean, this burnt up all its bearings because it was revving so hard before, and it just burnt them all up. Yeah, so, and now I've slowed it down to a more reasonable speed, 12,000. I wonder if I can show you. I've got a dyno reading here somewhere. Let's have a look. Yeah, I think I've got a dyno reading somewhere. I've just got to find it, lay my hands on it. I did some, oh, there it is. Yeah, I got a actual dyno, some decent dyno paper. So it shows you the RPMs, and she's making, can you see that? So that's 11,000 and 12,000 RPM. I mean, she's pushing just over 12,000 RPM. That's where she's pushing 8 horsepower there. Okay, now the reason that line is thick is because I've got a couple of different readings. And what I do, I note it all down here, because as you know, I do my readings on my dyno on my phone. And then basically I pick out all the readings, log them all down, and then I do a graph. But as you can see, it starts going up. Well, we're looking at what, 2.6, 3.2 horsepower there, but that's the standard horsepower of these chainsaws. 3.1 actually, but that's the standard horsepower. We've got a little dip at about 7,000. I'm not 100% sure why it dips slightly there, but because it goes up here and then it just dips around 7,000, then it starts picking up. And here we're hitting 5.8 horsepower. That's at approaching 9,000 RPM. Then it goes up to 6,000, 6.6, about 9,500. It seems to like the RPMs really, this setup. And we're looking at, well, we're looking at 7 horsepower here from around 11. So from 10,000 we're looking at in the 6 horsepower range. 11,000 it's pushing 7 horsepower, and at around 12,000 to 12,400 we're hitting 8 horsepower. Then as it's going faster, we're starting to lose it. 7.6, 5.4 as it's dropping down. Okay, so it's quite a good power band. I don't understand quite why I've got a glitch at 7,000. I'm not sure, I'll be honest with you. Something to think about, I suppose. But when you're using this saw, you don't kind of notice that. It just feels that it's going up as you're using it. It's, you know, it's a great usable saw. Like, so there's my that's my dyno reading. What I want to do is I'll do a standard one, because I've got a standard Sanoa. I'll do a standard one, and I might draw that on against that one so you can sort of see the actual difference. But yeah, I'm happy with this chainsaw now, and now I've put that bracket across. It was the only issue. I've used it for quite a while, and it was the only issue I've had. It made the carburetor come loose. I did think it was something worse, but it's not. The carburetor just came loose. So she was drawing in more air, started to backfire and hesitate, misfire. It was doing all sorts. So now I've got this bracket on. I'm fairly confident it's going to hold together okay. I've got a problem with one of the other ones that I tuned up. Unfortunately, this is the one with the 2 outlet pipes on the front. This is a Timber Pro, basically. Timber Pro chainsaw, good chainsaw. Now this pushed 5.9 horsepower on my dyno. This build I did before this other one, and obviously I improved this one. Now this, what's happened with this, I don't know if I've explained to you before or not, but the crankshafts on these Sanoas are just pressed together, and you know what happens if you push too much power through to them, the actual pin slips on the crankshaft, so they just do that, and then they won't start properly. You know, it draws air through the seals because it makes the ends of the crankshaft stir the seals instead of running true. So that other saw I'm gonna have, because this one's been welded. The crank on this one was welded because I had this issue on the dyno. As it was hitting 6 horse, it kept failing. I worked out that it was the crank twisting. So I've welded the crank on this, and I think I'm going to do the same on that one. I'll weld it up, you know, reset it, align it all up, and then I'll weld it up, and it'll should be okay. You know, it's just one of them things. They won't take the power. I think they'll go up to about 5, I suppose, you know, and then you hit much over 5 and the chances are it's going to slip on the pin. And that's the symptoms they give, is sort of crank seal issues, spitting back, bad starting, won't start, flooding because it can't get enough pressure to push your air fuel mix up to the combustion chamber, so it stays in the crankshaft and it just sits in there, puddles in the bottom, the fuel does. So yeah, as you can see, I've been doing a load of blinking, doing a load of wood right there. That was the last lot. Well, the last lot I did is still out there, the last lot I fetched, but that's when my saw failed. So I hope you've enjoyed this little one, just a quick one from Lutys Chainsaw Mods. Thank you so much for watching, and bye for now.